Let's learn how to use the debugger in Microsoft Visual Studio. I created a brand new application. It's a console-based application by doing a new project, and I chose Visual C# and I did a console application. And then the name that I used, I just called it Console App 2, and then I clicked OK. And then this is the source code that I typed in inside of the main method. So if you want to pause the screen, take a moment and type that in, then we can go ahead and learn how to use the debugger. The debugger in Visual Studio is a tool that we use that allows us to look and watch at how our program is working. We can inspect the different variables that we create and see what type of value they have at any time in the program. We can pause our program to stop execution or pause execution, so it works much like a VCR, which you might not know what that is, but or a Blu-ray player, where you can watch a movie and you can pause it and you can fast forward to another place, or you can jump to a chapter in the movie, and we have all those same type of tools within Visual Studio. So after you type this code in, we can just run the program once and let's see what happens. I'll start the program, and it's going to prompt us to say how many students do you want to enter for the grades, how many grades, and I'll say 3 grades, 100, 97, and 96. And it displays an average, and it just waits for us to press a key to continue. Now let's say that we were working with that and we had some problems in our code and we didn't really know what to do with that code, or how to debug it, how to fix the errors that were in there. Now if there's source code errors, the system helps you fix those, because you can't even run your program if there's source code errors. So those are what we call compile errors, or statements that we make mistakes on as we type them in. For instance, if I leave a semicolon off of that line, Visual Studio tries to help us fix those errors. But sometimes we have logical errors that when we run it, the program just doesn't do what we want to do, and we think the logic is right, and we try to go through it on the screen, but we just don't have a great idea. So what we can do is use the debugger to say, let's go through our program line by line, and here's how you do it. Off to the left of your source code, there's a gray bar area. That gray bar area allows you to click in it and create what they call a breakpoint. Now if you notice, I try to click on line 13, which is where my variables are declared. That one worked because I'm actually declaring the variable and then assigning a value. Line 13 doesn't work because it's just declaring a variable. That's not really what the system thinks of as being an executable statement, because that's not really happening during our runtime of the program. The assignment statement is, but just the declaration is not. So there's going to be some statements you can click on and some statements you cannot. What the breakpoint does for you is it acts like the pause button when you're watching a movie, or a stop sign. That's why it's red. It says, let's stop here or pause here and wait for you as the software developer to tell the system if you want to proceed or not. So if I ran this program right now, I set a breakpoint and I clicked on start, or the same thing as debug, start debugging. That would allow you to start the program, and now it made it to this line and it's waiting for you to tell it to continue. In fact, if I go down to the icon down below, let me change our screen down real fast so you can see. There's the icon of the output window. You can notice that nothing is being displayed yet. It's waiting for me to tell it that we want to display. I'm going to bring this back up. So I want to go ahead and step through that. Now let's see what this button is. The run execution to here. If I just click that button, my screen is now waiting for me to go ahead and start typing things in. Grades. And if you notice, it just takes off now. It just keeps going, and it's not waiting for me to do anything or go line by line. because that button more or less looked like the just continue. Let's look at it one more time. We get to this point. Right there it says you can just go ahead and run the execution of the program. It's the same thing as if I clicked on that continue button. So we're waiting to execute. This would say just run the whole program now. We're done waiting. Same thing with that. This button says you step into something. In other words, that would be like jumping to a new chapter in a Blu-ray. We can jump somewhere else in the code. This button says execute that line you're waiting on and just go to the next line. In other words, it's like you've got pause on a Blu-ray and you push play and it jumps to the next frame and now waits for you again. And then this one says go ahead and get out of that piece of code and go back to where you came from. So that would allow me to jump to a new chapter in a Blu-ray, and then I get to over there and I say, oh, I've already seen this. Let's just go back. And it jumps back to where I came from and waits for me to continue from there. The main one that you're going to use is going to be this one, the step over. So if I click that right now, which is the F10 hotkey, it now executed this line of code. And it's waiting for me now to tell it to go get data from the keyboard. Here's the output screen. It's now waiting for me to tell it I want to get data. If I press the number 3, nothing happens yet. And that's because this line has not been executed. We have to tell it to execute that line. So if I now press F10 or click on this button, notice that my waiting, or the yellow color, disappeared. That's because I'm now over here waiting to type something in. I type the number 3, I press enter, and now I come back to the program. So I'm stepping through this program line by line using this button, watching how it executes. Now the cool thing I can also do is I can put my cursor on the variables and they can tell me what values I have. For instance, if I want to keep track of ISUM and look at it throughout the whole program, I can look at it by putting my cursor on it, but the other thing you can do is you can actually inspect that variable by right mouse clicking on it and choosing Add Watch. By clicking Add Watch, it creates a brand new window down here for us, and it says here's the variable, here's the contents of it, and you can now watch what happens to it in the whole program. The other thing I could do is I could actually come down here and change the value of that variable. Now what's the purpose of that? It does not change the value of that variable in your program forever. It only changes it from that line until the program ends. The next time I come back into the program, the variable is right back to 0 where it left off, or it's back to its initial state. So all you have to do, change it. And the reason we do this is because maybe we want to do a what if. What would happen if the variable had this value? Or what would happen if the variable had this value? Other things I can do is if there's an expression, I can highlight the expression, right mouse click, and do a quick watch. A quick watch says, here's your expression, and there's the value of it. And I can type in any expression I want in that window and see what the value would be. I_num greater than I_count, and it says currently it looks like it is. What if I said, actually that one's still looking at that. If I went, let me change this real fast. If I went and tried to reevaluate, let's do a reevaluate on that. Let's go a greater than, and now click reevaluate. Now we see what would happen. So I can use that quick watch, right mouse click, quick watch, to do a what if as I'm running the program. Once again, this allows me to step through. So let's drop into the for loop now. First thing that happened in the for loop is it did that initialization. Now it did the expression. Let's see where it goes. Now it drops down into the braces for the for loop. And I just keep clicking. It waits for me to type in data. Enter a grade, 100. It comes back. ISUM is currently 100. Watch what happens when I execute that line. Now ISUM was 0. Now ISUM is equal to 100 because we took iGrade and added it to ISUM. And I can also confirm that by watching the variables down here. The whole purpose of this debugger is to watch execution of the program. Notice that now it jumps up to the third piece of the for loop, which is the increment. So that proves when we use a for loop, step 1, step 2, step 3, step 4, and we can see that happen in the program as we execute. So this is a great way for us to watch the logic of the program, watch the variables, check expressions, and see if what we think is happening really is happening. As I step through, now it increments. INUM is 3. Is INUM less than 3? No, we should see it drop out of the for loop. Step. And it does. D average is currently 0. ISUM is 293. ICount is 3. We can even check what that value would be. I'm just going to do that part. The int divided by an int. Quick watch. 97. Notice there's no decimal on it. Let's do it again and include, I'm just dragging and copying, let's include that double and do a quick watch. Now we see a decimal place on it. Step, step, step. So the debugger, as you can see, is a great way to watch your program. If you ever get to the point in your debugger where you just want to keep going until you hit the next breakpoint, just click continue. And you can actually have multiple breakpoints in your project. Wherever you think there's a problem, you can run it. In fact, let's do that one more time. I now have 2 breakpoints in my project. I have one here and one after the for loop. Let's start the program. We're waiting to execute. I'll step that line, step that line. How many grades? 3. Come back. I know the for loop works great, so I set a breakpoint down below the code that I know works. So I'll click continue, and the program will just now run normally until it hits the next breakpoint. So that's a way you can run code that you know works and stop at the code where you think there's a problem. Let the debugger help you. It's a great way to solve logical errors in your program.